method. What you learn, the traditional method being used. As we have seen, there is some limitations in every method we learn, maybe about core method. So we are going to go through this in details, what we are facing and what we need, the next step. So our aim always to develop a appropriate framework to analyze longitudinal data using the most effective modeling that could handle missing data, could handle variance covariance, obstructions. So all of this is what we're looking for. The traditional method may not address our concern. Now you need to be familiar with the examples, real world example of longitudinal. So I give you several examples in your midterm exam. That a real example of data is still under review for publications. There is one paper already accepted, so it will be published soon. I am the BI of that project for your midterm exam. Like this is another project. You can think of any other example that you can generate, or you can help other clinicians to develop, such a project. In Saudi Arabia, there is no much of this kind of project. Most of the study cross-sectional. I think we need to move away from cross-sectional to perspective, study design, because they are more valid than cross-sectional. In cross-sectional, what the limitation of cross-sectional study?
One point of view.
Limitations cross-sectional.
One time.
One time.
Point of view.
Concept.
Give you the prevalence, not the incidence.
Okay.
Giving all the ratio or
There is no cause and effect. The cause and effect, this is the most important.
no causality.
Yes, no causality. You cannot assume that, this drug effect this or that effect that. So that most difficult time for cross-sectional. Now here you can address causality, because in this perspective study, you can exactly find differences between treatment, and this is how the clinical trial, all clinical trials use longitudinal, assess over time. So you need to know how you come up with a research question, you need to know how you set up the problem itself with the clinicians together, how many reading that can be assessed depending on the drug effectiveness, what kind of drug, how many drugs that you need to assess, number of samples also you need to calculate. All of this, you need to make sure that you can help with it. So, and this is an example looking into investigations of the effect of vitamin E on the growth of 20 rats, which were observed for 3 weeks. So this is not in human, it can be also in animals. This is a clinical trial. Before to apply the drug in human, first they tested in animals, right?
Yes.
And then again they start with phase 1, phase 2, phase 3, phase 4 in human. So even after this, they come back and do the phases of human. So in the beginning of the study, they received different amount of vitamin E. So there is different amount, either 0, right, depending on the dose, or a 2 in appropriate unit. It can be any unit that they're measuring. So a 0, nothing, versus 2. And then there were 10 rats for each treatment group, and each rat was weighted at week 0, which is before treatment, week 1, week 2, week 3. Okay? So what we are looking here, what is our outcome? Growth. Thank you. Looking at the weight of this rat that they gain during this period of time. by giving these vitamins, two level of vitamins, right? So now, and as you can see, the over time, so they measure it at week 0, week 1, week 2, week 3. So how many time points? You have 4 time points. Now you can think of how you're going to model this using the traditional or the approaches that we already used. So can you help me with that? No? So, do I need this? Yes. So the question here, how if you address this problem, how are you going to help with the analyzing this using the traditional only?
ANOVA.
So the first thing it comes to your mind, ANOVA, right? Repeated measures ANOVA.
Yes.
So because likely they try to test differences in weight over time. Between what? Differences in what? In treatment, right?
Yes.
Which is vitamin,
E.
yes, depend on dosage, which is 0 or 2. So yes, you're looking at the hypothesis here, testing the differences in weight by treatment over time. And how you do that? A repeated measures ANOVA. But this is before looking at the assumption, right? Then we have to look at our assumption, generate our code, which is the same code you just run, right? So the same thing. You need to model it, look at the test of specificity, right?
With a method, not method.
Yes. Which is Miyushi. So if it's significant, that means ANOVA what? The specificity violated, you cannot report ANOVA p-value, right? So you have 2 other options to check,
ANOVA.
which is greenhouse or MANOVA, right?
Yeah.
So now, likely, if you try MANOVA, then you need to check the assumption of MANOVA, which is box M, right? Yes, yes.
One of the lecture you mentioned lower bound. Across of the lecture, you mentioned lower bound.
Lower bound.
One of the lecture.
هنا؟
We can't take it. لا في المحاضرات السابقة. You mentioned 3.
Yeah, lower bound.
Yes.
That's another test.
Yes, اللي هو
Greenhouse case.
جرين هاوس، والثاني مانوفا، والثالث lower bound.
Lower bound also adjusting degrees of freedom.
طيب وش تشوف؟ anyone؟
Because there's a comparison between lower bound and greenhouse. Always use just a greenhouse to report it. Yeah.
From the beginning, the group of 20 rats not met the assumption. So.
Thank you. This is why you need to check the assumption of MANOVA. So yeah, the M box checking what? Checking the normal distribution, remember, of the multivariate variables, and taking at the same time also the homogeneity of the variables, right? So yes, here you will not assume MANOVA if you have an equal variance covariance. Why? Because you have only 10-10 in each, and 10-10 is small sample size. At least you need a 30 to say is a large, right, in each. So in total you need 60. So yes, while you are doing or producing the what is called box M, is you're going to generate a p-value. This p-value testing 2 things, testing the normality, and also testing what? The homogeneity. So if you have a large p-value, good. That means normal distributed, and also you make the homogeneity test.
So the
So
assumption.
now you can report the MANOVA. Yes.
So the assumption will be not normal distributed.
The hypothesis or the
The
assumption?
hypothesis.
Yes, the hypothesis is saying normal distributed and homogeneity met.
Okay.
And the alternative says not normal distributed and homogeneity not met. Yes.
Significant.
Yes. Now, if you decide that you're going through the MANOVA, if you say you fail to reject the null hypothesis of the homogeneity and the normality, then you have to use what? MANOVA, right? So in MANOVA there is 4 different tests, if you remember. Maybe
Wikileaks.
Yes, with lambda, hoteling, and there is other techniques. So with lambda is more appropriate to be used.
طب السؤال لو سويت transformation
Of what?
للداتا from non-normal distributed to be normal distributed,
Yes, that's another option. Good.
can I apply it also?
Yes, you can try it to see whether you're gonna get
But in that time I'll take the median.
why.
The median, because it's
No.
originally not normal distributed.
Once you transform it, then you go with what the transformed value. Let's say if you use the log,
Okay, look, like
right? So
like-
you change your data to the log. Now you're going to do all your analysis using that log. So you have to redo again your analysis with SAS based on the new data that you get, the transformed data. Right, so this is how you analyze it, using the traditional. Now, there is more tests you could do, which is per sample t-test, right?
Yes.
But we know there is a limitation. So per sample t-test, how many time points we have?
4.
4. So per sample t-test, you will do how many tests? 0 versus 1, 0 versus 2, 0 versus 3, 1 versus 2, 1 versus 3, 2 versus 3.
9 or 10.
This is too much, right? And also, this is ignoring what? The effect of treatment. I never mentioned treatment here.
Yes.
I just mentioned the how the baseline weight compared to the weight after treatment, 1 week after treatment. I did not mention what treatment that they given. So this also the per sample t-test ignoring what? The treatment, ignoring
Intermediate.
Effective treatment.
the whole conversion, right? Over time. I cannot say the difference is over time, right? So this is an option. Now, ANCOVA.
It's the same.
I could do ANCOVA.
Yes.
It's the same.
One treatment.
Yes.
The baseline.
The good thing with ANCOVA,
Not ignore the
it can
treatment.
include the differences in treatment, right?
Yes.
But ignore what? It ignore the 1, 2,
1 to
1 and 2, which is intermediate. It's going to utilize the 3 as an outcome
independent.
and a 0 as the independent,
Independent.
and then the interaction between the 0 and the treatment.
Endpoint.
So it's still the ANOVA test or MANOVA, whatever we decide, or greenhouse, remain the better test for this. Okay. Also change score analysis, that's another technique, which is subtracting the 3 minus the 0, right?
Still the same.
Change the score.
But also you're ignoring what? The intermediate.
And the effective.
So all of this, the 3, just you can tell the differences now here in details, how these approaches works and what the limitation of these approaches. This is why we need to move next week, inshallah, to a different statistical modeling, which is called mixed model. Okay, it's going to help us with even include missing data, even if the variance covariance structures, if it's not surface estimate, still we can utilize it. We have different variance covariance structures. So now per sample t-test, this is how it works. So you have you're looking for differences between 2 measurements only at a time. We cannot do what? Group treatment comparison. We know it. 1, correct? It ignores intermediate data. And this is how the formula for that. The change score analysis is also another option. It's more complex than per sample t-test because it's going to take the differences between the final point and the baseline and then compare the treatments of these differences. So this is also to ignore what? Intermediate data, correct? Because it's going to ignore time 1, week 1 and week 2. It's going to only take the difference between 3 and 0, right? So this is another issue with change score analysis. The classical approach here, now we can test over time. But also ANCOVA ignore also
Intermediate.
the intermediate part of it. It's gonna consider the final point, which is as the dependent variable, and the baseline would be week 0, right? But also lacking of the intermediate measurement.
We can analyze the change in score as in a cover.
Yes. So also here you're taking differences, and then again you're going to include
So when
the
we use
baseline. For which one?
يعني what's the study شو الستادي اللي تخلينا ناخذ السبستراكشن ونسوي له analysis.
ده بيسموه change score analysis.
I know that the technique itself. لكن what is the study? يعني can you give us give an example?
Well, the same study that we give نفس بتاعت الرات هذه.
But if I apply the rat study and do PRT test or score analysis, so what's the difference? It's a matter of what to choose or what.
لا
I
انت
want to
research hypothesis شنو كان؟ It's always the research hypothesis حتى لو ما قال لي هذا research hypothesis. As a statistician, I should tell what would be the research hypothesis. So basically, they giving treatment, right? They measuring weight over time. So likely, yes, I can come up with a research question which is looking at differences in weight by treatment over time. And now we come up with a statistical technique.
So in these questions, I will do score analysis, score change analysis.
You could do it, but you're not 100% addressing the research question.
So what will be the research question for score analysis?
The research question, just similar to the covariance,
Yes.
ANCOVA, which is analysis of covariance. So here you're looking to control for what? The effect of the baseline
صح.
on the endpoint, controlling for the treatment.
Yes.
And the same thing, the effect of treatment, controlling for the baseline on the endpoint.
صح.
So it has different research questions than the one for the ANOVA.
I got your point.
Do you see that? Yeah.
But if I do an ANCOVA and the analysis of covariance of post test score, I can know that I am looking for the treatment, so I will utilize the last point or middle point as my target, and I will run.
Yeah.
But what is the hypothesis that make me, instead of doing that, please go to subtraction and take the score change?
The similar hypothesis. The researcher must give an indication of this is what I wanted to test. Like whatever they say, I wanted to test this, controlling for or adjusting for the baseline, then I would not think of ANOVA. One is whenever they say, I wanted to see the effect of treatment adjusting or controlling for the baseline. So this is similar to the midterm exam.
Yeah.
Directly, this we're talking about ANOVA. But if I say I wanted to test differences in treatment, differences in weight by treatment over time.
Okay.
So I'm talking here about what?
Score analysis.
No. Differences
Difference.
in weight by treatment over time.
Repeat, please, Rano.
Repeatedly. It's ANOVA. But if I say I wanted to test differences in endpoint, okay, by treatment, adjusting for the baseline.
ANCOVA.
This is ANCOVA. Yes. And if I say I want to see the effect of treatment on the endpoint,
Okay.
and it is in relation to the baseline.
ANCOVA also.
Could it be a pair sample test? Could be.
But there is adjustment.
أنا ما قلت differences in treatment.
Okay.
دائما ال endpoint always there is a treatment given, right?
صح.
So now I can make just a pair sample test, the endpoint with the baseline. So, but if I said I'm looking for differences in the response by treatment,
No.
then over time, then this is clearly ANOVA. So we just need to make sure that we understand the research questions and what the researcher wanted. This is very important. Now for repeated measures ANOVA, it's simple, we already explained it, right? And repeated measures MANOVA,
Only last one. The change.
هذا I said
Last one. Change.
دكتور
نفس
دكتور
هذه قريتها قبل الاختبار.
كويس.
دكتور
Yes.
إذا كانت السامبل سايز أقل من 30 طيب وسوينا السبيسيفيتي تيست والأنوفا والبوكس إم في المانوفا وشيكنا النورماليتي من البي فاليو إذا كانت لارج بي فاليو خلاص ما عندنا مشكلة في التستين
للإمباكس وللسبريسيتي مو يوشي.
يعني في حال إنه كانت نمشي البي فاليو
Large.
لارج حنمشي مع الأنوفا لا إذا كانت أقل حنشوف المانوفا إذا كانت لارج خلاص ما عندنا مشكلة.
تعمل المانوفا.
أيوة أسوي المانوفا.
إذا كانت small that we cannot do maneuver.
ولا شو أسوي؟ حنسوي جرين هاوس.
Green house, again the green house.
check normality by B values
تبعت المانوفا yes.
والأنوفا.
الأنوفا هذيك checking السبريسيتي only.
طب كيف حنشوف النورمال؟
النورمالity also like you either you do it manually or you look at the sample size.
small sample.
هذه تبع الأنوفا صح؟
أيوة small sample.
So the test for sapricity only testing sapricity does not test normality like the MBOX.
Do you generate a graph?
You can do histogram for every yes for every measure and see whether normally or not.
For every measure?
Yeah,
There is no.
and by treatment, every measure by treatment. But if you have a large sample, you don't need to go through this.
We are talking if we have a small.
Yes, if you have a small, you may need to do this manually. Do a histogram for every measure, but yes.
If I do a Q plot,
Yes, Q plot also will help.
splitter or the same.
Also visual. Yeah. You may say normally, I may say not normal.
Yeah, this is the problem.
It's a
Is
visual. There is a test.
A factor or coefficient factor.
There is a test you can test for normality. I think Shabiru or something like that.
شكل
Shabiru.
شبير.
محطوط مياه.
W
Epidemiology.
by W.
Yeah.
ها؟
Shabiru.
لا لا W. ما أخذناها قبل. W value. Is there a cut
Epidemiology.
off?
محطوط مياه في epidemiology.
الأخير.
شبير.
لا أول مرة.
هذا أول ما دخلنا المحاضرة هنا قلت تعطيني إياه. افتكرت. سألتك سؤال قلت لك how we test the normality.
Okay.
What we do if it's not normal.
هنا أوريك.
ها؟
الحين أوريك إياه.
إيش جزاك الله
إن
خير.
شاء الله.
قاعد تقرا فيها ما فهمت شبير W value.
Yeah, there is a test for normality. It's called Shabiru, but myself,
Never done.
I don't like to use it. I just either do visual, the histogram, or look like the sample size if it's large enough. Then I don't have to worry about the normality.
We need expert here.
So that
You need expert.
شبير هذا ما عمري مرات فيه إلا مرة.
I'm just gonna look for the leg. So I have the treatment here. I have these. So let's say I wanted to test normality at the baseline, normality at the week 6 as well. Visually, you could do histogram. So you put the variable here normally, and you may include treatment as well in here, the row. So this will give you
Visually not normal distribution.
Normal distributed.
الخطر عشان تقيس قارن.
Normal distributed.
I added this line.
Yeah.
So
Just
the
put
line,
the button.
how you do that is here, histogram. So you put the
Display normal.
quantitative
Okay.
one as variable. You put the treatment here. You could put it as column as well. So you get something like this, right? So to me, based on the number, you say I'm assuming normal, but based on this, we'll see the test. So if you want to test the exact, was it normally or not, so you look at the analyze. I think there is
This is not normal.
في other tests اللي هو crosses.
Explore, maybe we'll do it for you. Explore. So you could also, I can do it for all 6.
Okay.
The factor should be here, treatment. Plot, if you're interested in a plot. Again, the histogram, same as the histogram that we just generated. You can ask for this. Steam and leave.
رافد. هذا حركة رافد. ما تنفع.
هذه yes, أكل الدهر عليها صراحة. So I'm gonna uncheck this. Just gonna bother me لما أشوفها صراحة.
خلينا في الهيستوجرام.
So histogram yes is better. What is this?
ماني شايف.
Normality block.
Normality. Even histogram, since we have normal to plot and a test, with a test. So I need to check this, right? Yep. So this is only you need to uncheck this thing. It's by default this thing here, right? So uncheck it. You don't want to see this. Only check what normality. Continue. I don't think there is any other options you need to check. So
Outlier.
if you're looking for outlier,
No.
I think. Yep.
This is the key to go.
So the first one, give you just descriptive statistic. It's not important. I must check that. This is the normality test, which is more important. And how we interpret this, as you can see, normality give you for at week 0. This the patient in treatment A, the patient in treatment B, placebo. Whether these are normally distributed or not. So if it's insignificant,
That is normal.
that is mean normal. But if it's significant, that mean not normal.
It's يعني not normal.
Yes.
Significant, not normal.
If it's significant, not normal. So what is the hypothesis here? Hypothesis says normal, not normal.
Same like reality.
Yes. So now this is what the Shabiu is. So at week 0, none of the patient in A drug and a placebo drug they normally distributed in the measures of play. Also, actually in week 1, only the patient in placebo, they are normally distributed. You agree? Because it's larger. In week 4, only patient in A drug are what? Normally distributed.
Yes.
In week 6, both of them not normally distributed.
So none of them normal.
None of them are normal.
Because I've done it.
So now,
greenhouse.
this is a not normal. No, according to MANOVA, there is a test for that. It's going to take care of this. But now we're just addressing the individual normal. You don't have to do this to decide whether you need a MANOVA or not. We have a test for MANOVA, right?
The box then.
The box M. Yeah. So now this is what we addressing for ANOVA itself, right?
So when we start plotting our data, whatever was the
Exploring just your data.
explore. The QQ plot.
Yes, this is testing also the normality visual. How you interpret this? This is the treatment A, lead level at 0, week 0. So we like to see this data along the line, not diverse from the line. So as you can see here,
Could be outlier.
I was concerned about this. So, but all these are good, looking like a normal distributed. But concerning about this, maybe not normally distributed or causing an issue. This is also, what do you think about this?
Also
Outlier.
could be outlier.
So anything far away from this line
It's not normal.
indicate what? Not normally distributed. This is called QQ plot for normal. So if you don't want to look at the Shapiro, you can look at these.
Doctor, we should just test the normal distribution in the baseline, right?
Yeah, this is for the baseline. Every time you test it for the baseline and even post-treatment
Why we need
for a different level. Yeah, if you're interested, you could do that. Yeah. But likely, ANOVA at the ends concerning what? The suppressity. And suppressity most of the time does not meet, correct?
Often number.
So this is only in your quiz.
Dreams.
أعطيكم إياها
In my dreams.
I make up number يعني ما شيء real.
Often not met.
Ah.
Rarely we use it.
Yeah, so it's not real, but just only to assess your knowledge. What you do.
أصلاً طماعين اليوم صراحة.
على إيش؟
We want to ask you for money.
دكتور أنت كريم صح؟
ترى اسمك في الدكتور انور كريم اللي
وين؟
كريم انور.
وأنتوا أكرم
والله أنت
مني.
معروف مرة كريم.
وأنتوا أكرم مني.
This is the outlier.
يمكن دكتور محتاج
Yeah, so all this
Yeah.
good.
بليز يعني بطلوا تقولوا انه لازم يكون في فاريشن في العلامات والاشياء دي خاصة بالليل هناك
قول الدكاترة مخمين هذا يقولون لنا غريش
الدكاترة يقولون كذا؟
كلهم طيب مين اللي حيظبطنا؟
ما في تعرف لي المرة اللي فاتت الامتحان اللي فات الفاينل جريدنج الماتيريال وكذا ف للفايف بوينت تعرفين بيحاولوا يشيلوها يقولوا لي لا ما تحطها لانه بتبرينج اب كلهم مثلا.
طيب دكتور احنا 9 صح؟ سوي لنا نورمال ديستريبيوشن الحين اذا طلعنا نورمال زيدنا بونس. اذا طلعنا سكويد
احنا طالعين طيب الله يرضى
لا إذا بالعكس اذا طلعت نورمال ده احسن شيء. اذا طلعت نورمال it means well.
لا طلع سكويد لاني قلت
لا اذا طلعت نورمال what that means.
تسمين انه ما حتعدلنا.
ما في فاريشن.
انت you need a perfect.
No, 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 no.
احنا نبغى سكويد.
She wants something else دكتور. I know her point. إذا normal معناته إنه في ناس.
Yes.
إيه.
The normal mean look at the normal.
احسن
The normal means that you have 5% F,
أيوة.
5% A plus,
حشرنا.
10% A,
بس ما
لا الحين غير cut off دكتور.
20% the B, and
غيروا الكتوف حق البي فاليو. they're
الجروب
thinking
يا دكتور
to redesign الكتوف.
لا تحط
دكتور حتى ال 5% ما